Hello everyone, and welcome to another video. It's been quite some time since I've created another one. I did upload a little one yesterday just showing, oh actually might have been earlier today, but showing Looking Glass with a new upcoming feature that hopefully we'll see in mainstream soon in the master branch. The topic of this video is though going to not be the future incoming features, but we will touch a little bit on that later. It's going to be all about the upcoming release of Looking Glass Beta 5 or B5. It's imminent. We've just put a hold on the release for a little bit so we can do a few things like make this video, as well as I believe Wendell of Level 1 Text is also going to be creating some content to coincide with its release. So we're just delaying a little bit, but by the time you see this, it may be released or very, very close to be, or to be tagged, I should say. If you don't know what Looking Glass is, I'm going to do a little bit of a recap or a little bit of explanation here as best I can. It's a topic that's a little bit hard to explain. It can be complex. If you know what this is, feel free to skip over this part. Looking Glass is a tool that I've spent the last now probably close to 3 to 4 years working on, that allows you to use a virtual machine inside of Linux with a hardware accelerated video card. Now it might sound like a tool that's not that flash. We've all seen virtual machines, we've all seen VirtualBox or VMware and so on, being able to do fancy things, but not probably as fancy as what you're going to see here. The technology we're using is called VFIO, or Virtual Function I/O. It's been around for a long time, and it's used in commercial environments. In the past, it's been used to give a physical device, like say part of your network card or even a whole network card, the actual PCI card that plugs into your motherboard, to be able to give that device to the virtual machine for its sole use. And then the virtual machine has direct access to it, and because it has direct access to that bit of hardware, it gets extremely good performance with that device. It doesn't have to go through the host or translation layers and so on. Over time, the technology's evolved, and we're now at a point where we can pass a video card, like a high-end NVIDIA or AMD graphics card, into a virtual machine, as like put a second card in the PC and pass it into the virtual machine so it has sole use of that card, and then it gets full 3D graphic acceleration. At which point, with the other accelerations that are in modern CPUs, like AMD SVM, Secure Virtual Machine, and Intel's VTD extensions, we're practically getting near bare metal performance inside a virtual machine, allowing you to run Windows and maybe your productive applications like AutoCAD or Fusion 360 or Photoshop, you name it, but as well as run AAA game titles that have just come off the shelf with 100% compatibility. And the result is absolutely outstanding. So what I'll do is I'm going to do a little demo of Looking Glass. I'm actually going to use the current bleeding edge version. It's about to be tagged B5, as I mentioned prior. Just show quickly what this is. So I'll switch over to my shared view. So here we are on the desktop. Now, this is obviously a mess of code and text. This is because it's my development machine and I've been doing a lot of work on this. This video, I should say, is being recorded just after I did a whole heap of work on some upcoming stuff to do with Pipewire, which is really exciting. But anyway, I already have started a Windows virtual machine, and it is using a NVIDIA RTX 3090 it has access to. Now, that's a quite high-end video card, but you don't need to have such a high-end card. A lot of people are doing this with like older, even GeForce 970s, and I think we had a 760 user. Also AMD Vega cards and so on. Although there's some caveats with those, you've got to be careful with those ones. There's some reset issues, but that's not to do with Looking Glass. That's another topic entirely. But I have an RTX 3090 in my virtual machine, and on my for my Linux desktop here, what's running, all what you see in front of, I've actually got 4 monitors attached here, is being run by an old Maxwell generation NVIDIA Quadro K1200, which isn't a flash card. It's a productive card, but it's not exactly a gamer's card or a high power card. It's a little small form factor thing. It's quite a nice little thing for what I'm using it for here. So I'm going to launch Looking Glass. And this is going to connect to the virtual machine. And what it's now doing is it's taking the output of that GPU and displaying it on screen. The reason why we need Looking Glass for this is when you give a full GPU to the virtual machine, the video drivers, the NVIDIA or AMD, in this case NVIDIA drivers, don't know they're in a virtual machine, or rather just don't care really. And so they still try to put their video out on the physical connector on the rear of the card. So that's fine if you want to plug your monitor into the card. It's fine if you just have a dual input monitor, you can switch it between the two, or a KVM switch. You can switch to the monitor input over. And a lot of people do that, and it works quite well. But if you want full integration with the Linux desktop, it's no good. And that's the hole that NVIDIA fills. That's the problem it's solving. Also, if you're using a virtual GPU, if you've got, say, a NVIDIA Tesla or Grid, I should say actually, that allows you to partition it into multiple virtual GPUs, or if you're using the vGPU Unlock project, which allows you to use a consumer GPU and partition it, one of the NVIDIA cards, your video card that the guest gets, it's virtual, but it's still directly in the hardware. It doesn't even have physical monitor plug into it. So the only way to get a picture out of it is to use Looking Glass, or to get an accelerated image out of it is to use Looking Glass. So they're the voids it's filling. We're also filling a few more voids that'll be coming in beta 6. We're fixing a few issues with the audio support of these virtual machines, because there's been a lot of prolonged issues with that, but we'll cover some of that later. But for now, we're just going to show what Looking Glass can do. So this is like I said, a virtual machine running inside of Linux. You see that my cursor integration with the virtual machine pretty much flawless. There are some little glitches with that still, but for the most part, it's flawless. Like, it works really, really well. We can make that go full screen with a shortcut if we want. You don't have to, of course. And to demonstrate the kind of performance we're getting, I'm going to run the superposition benchmark, and we'll just run part of the benchmark itself. We won't run the whole thing. So if you're unaware, this benchmark puts an extremely high load on the GPU. You need a high-end card to get decent frame rates out of it. Now, Looking Glass isn't a free lunch. It does put a bit of load on the card, and depending on your workload, it can affect performance probably up to 10 to 15%, depending on the resolution. If it's a lower res card, it's far better. But in this case, yeah, it's maybe 10 to 15% for this benchmark. If you're playing a game that's not so loading, like doesn't stress the card up as much, or running an AutoCAD program or something like that, that's not loading the card up 100%, Looking Glass may only be using maybe 2 to 5%. It really depends on your use case. So don't expect Looking Glass to perform as well as having nothing running at all, because it has to do some work. But that said, as you can see, we are getting flawless output from the virtual machine being captured into OBS, what I'm recording with. Now, I'm actually just capturing the Looking Glass client. If you're a streamer or you like to record content, there's actually a plugin that I've written too that allows you to take the feed from the virtual machine straight into OBS without having to recapture the screen on your monitor. The advantage to that is that there's less overhead, the latency is lower, and some people will actually feed that into OBS and use the physical monitor output to actually game on because they're more comfortable with it, or maybe they want lower latency in some setups. It can actually improve things depending on what you're doing. So there's a lot of configurable options in the setup of this. But as you can see, we're getting like 100 plus frames a second inside a virtual machine, which is, in my opinion, amazing. So we'll stop that. And we'll move on to the next thing. Now I've shown what Looking Glass is, I've got to thank some people who have been pouring a lot of their own time into this project, especially Quantum. He has put a lot of effort into some large feature sets, also with things like the I don't think the name of it, but the builds, the automated builds that are happening on GitHub. He's done a lot of work to make sure we're building every possible configuration of Looking Glass on every code commit, looking for bugs and problems and all sorts of stuff. It solved and stopped a lot of issues with support. It's been very helpful. He's also put a lot of time into some features we're going to discuss soon, like damage tracking, JIT render, some of the overlay work, some of the DMA buff work. He's basically touched on almost every aspect of Looking Glass in some way that is very positive. So a lot of appreciation to Quantum for his efforts here. We've got also Zain, who is sort of also one of the people that's contributed to the damage tracking. He works a lot with Quantum as well on these things, but his time doesn't allow him as much on the project, but when he can, he gets in and does what he can to help, as he's already stretched pretty thin across other open source projects like Sway and Wayland stuff as well. I'm not sure exactly everything he's involved in, but yeah, he's contributes to quite a few open source projects. We also got JJ Arcop, who does our Discord management and also documentation for the project. So if you've got a problem with documentation or suggestions, he's the guy to get in touch with. Easiest way is on Discord. If not him, you can always maybe ping myself or one of the others. And yeah, it'll get attended to if there's some suggestion you have that would help things. Netboy3, he's also one of our Discord users, and he also contributes to documentation, but also does testing on the project. He's been very helpful in making sure that things behave properly or providing good debug reports with videos and so on to help me or Quantum or whoever to replicate or even just see what's going on so we can replicate faults and track them down and fix them. And finally, I'd like to also thank everyone that donates to this project. Without your donations, it wouldn't be where it is today. The project is massive. It's a lot bigger than I would have ever expected it to have grown. It's got a lot of features in it that I actually never envisioned, because initially this program was written as just a tool for myself. I didn't realize that there was going to be such a big interest in this at the time. I thought it was pretty niche what I was doing. But yeah, what do you call it? The niche has sort of exploded into a large group of people that are now using it. And yeah, your donations help greatly. But if you're not donating and would like to contribute to this project to help me justify the time that I spend on this and justify purchases for the projects, or for the project, I should say, things such as code signing certificates, hosting, although hosting I subsidize from my business, so that helps, but it's still not free, as well as hardware. For example, recently I had my GPU fail. I had a 1080 Ti that packed it in, and with the scope of the world at the moment with the chip shortages and the scalpers and so on the GPUs, getting one at short notice was just about a nightmare. But if it wasn't for our community and the support being provided, I wouldn't be able to do this work at the moment. I would have been out of action. A huge thanks to Level 1 Techs, Wendell over there. He's been helping to support this project through hardware and giving it exposure across on the Level 1 Techs channel as well. also been quite a while ago now, but we were featured on Linus Tech Tips on one of the videos with virtualization, which was pretty nifty. So thank you to everyone there. But like I said, if you haven't donated, would like to, you can donate through the website. We have various methods. You have Ko-fi, Patreon, PayPal, Bitcoin, or Ethereum. They're all basically the same to me. You can also donate through GitHub sponsors. I'm not sure why that link isn't on here. It should be. I'll have to resolve that. But yeah, I'll put a link in the description down underneath the video for that one if you'd like to do it. And GitHub sponsors actually is the one that more of your donation ends up being received by me. There's no fees attached to that, and so on. GitHub don't take a cut, and they've got an agreement with Stripe, who does the payouts. So there are no fees attached with donations to projects hosted by GitHub. You're using the GitHub sponsors. But if you don't like that platform, feel free to use any others. There's no expectation or push to use any particular platform, whatever you're happy with. And if you do, thank you very much. It really does help. If you'd like some merchandise, we have merchandise. That link used to say shop, so people may not have seen it or missed it, and you can buy some apparel, some clothing. You can buy the mug. I quite like the mug. I have one right here. It's been serving me faithfully for probably 8 months now. And the print hasn't come off it. It's printed well. I'm pretty happy with it. This one's actually the first revision of that, where the bottom half's got it's not going to focus. It's got a different address on it. It's got the lookingglass.rocks address on it. But yeah, you can get some clothing if you'd like something to donate, and a small amount of that comes back to the project as well to support this. Something also that has changed, a lot of people haven't picked up on, is we actually have no longer just a wiki, we actually have documentation. Thanks to JJ Arkop, as I mentioned earlier, he's been helping to set up, what's the tool called? I've forgotten the name of it now. Sphinx Doc. We're using for documentation, and you can go to the installation and that'll drop you into the documentation, or you can just go to /docs. We're looking at the B4 documentation. Like I said, B5 is imminent to be released, and when that does, this will update to B5 for the stable link. You can also go B4, get the B4 docs if you need to go back to them or whatever. These are all also available on the download page. You can choose the documentation for the version you're interested in over here. There is a little purple book. So for example, we can go back to B4 RC1 and look at its documentation. So when B5 comes out, there'll be one for it. As you can already see though, we already have B5 RC1, and there's the documentation for that. So we are trying to maintain this and keeping the documentation versions matched up with the version you're running. If you decide not to upgrade, or you need to run an older version because there's a bug in the new version we've missed, or some issue with the way you're using your workflow, the new version may have changed or broken. We also have Discord for support. I mentioned that earlier too. JJ Arkop also is helping to manage that side of things. I'm in there most of the time. If I'm not, usually it's because I'm sleeping, but I have a pretty messed up time schedule because of work and stress and, you know, typical nerd schedule. It's pretty abysmal. But yeah, I'm normally around in there. So if you want to say hi or want to come and have a chat, or if you've got problems and need a hand, that's probably the best place to go to get pretty rapid response and pretty one-on-one help. But just remember that we're doing this out of our own time and pockets, and if we can't respond straight away, just be patient. If you want to use another platform and leave a message, we also have the Level 1 Tech forums. You can go to level1techs.com/LG. It'll actually take you to this page, and you can create a topic in here, and either one of the guys on the forums will get to you, or I personally will at some point pick it up and do what I can to help you. If you are reporting a bug or a problem, especially with the V5 release, hopefully, like I said, this will be out probably about the same time this video goes up. Make sure you give us your logs. A lot of time is wasted when people come into the chat and in Discord, or they'll open a ticket here, or not ticket, sorry, open a topic here, and they'll just say, oh, such and such crashed. It tells us nothing. We need the logs. The client application, when you run it from a command line, if you run it in a terminal, it dumps a whole heap of debug and diagnostic information out. We need the whole lot. Don't just snip out the crash part or the bit you think that is all we need, because the extra information preceding that tells us how your system is configured, so we can make a good estimate and judgment on what led up to that crash. So please provide the whole log. If it's an issue like, say, the host application isn't starting or running, the number one cause of that is failure to remove the virtual video device from your virtual machine. Make sure that you have removed the QXL device from your virtual machine before you submit a bug report or start looking for help. The Looking Glass host cannot launch if it's not using the primary graphics device. It needs to talk to the primary one, because the virtual device doesn't support desktop capture. It's missing that support in the DirectX API and in its driver. So Looking Glass can't even launch if you have that on the system. The other option is to disable it in Windows, or make the NVIDIA card or your primary GPU, the actual physical card, the primary graphics card when Windows comes up, at which point you can start Looking Glass and it will work. But the easiest way to do this is just to remove it from the virtual machine, and then you won't have that problem. But that said, if you do have a problem and the host isn't running, make sure you send us a log. The log's pretty easy to find. You've got it in the start menu. Firstly, you can look it up, Looking Glass host, like Looking Glass logs, and we'll take you straight to them. There are two logs here, the service log and the host log. The service log is not very useful. The host log is the one that will explain why your system, or why Looking Glass is not running in 99.9% of times. I actually don't think we've had a need for the service log contents for a bug report in probably a year now. It's not very handy to have that one, but we'll ask for it if we need it, so don't worry about that one. If this file is huge, in my case it's quite big, it's 630K, there's probably thousands of lines in the log at this point. Delete it, try and run the host so it creates a new one, and then send us that one. If you can't do that, just copy out the last probably 100 lines and send that to us. If we need more, we'll tell you. But that log is appended to it. It's never overwritten or removed. It'll just keep appending. If you're going to use Discord for support, that's fine. If you're pasting logs, put them in the log dump channel. We have a place for that, and then jump into the support channel and ping one of us, or just say, hey, I've got this problem, my logs are here, and explain what's going on. But without your logs in hand, we can't really do anything. If your logs say that you have, say, the Microsoft display adapter is showing in there as your graphics card, that means you haven't removed the virtual device from your virtual machine, or you have not installed your video drivers. If either of those are the case, fix that first. If you've tried to fix it and it has had no effect, then get in touch. But usually that's what the cause of that is. All right, so let's move on. That was documentation we've talked about. We've talked about Discord. If you want to join Discord, the link is on the website over here. Take that in and we'll join. We've got 910 members at time of recording, which is pretty massive. I didn't expect we'll get that many in there, but that's pretty cool. And a lot of us are very active in there. So if you just want to have a chat, drop in. We've got a gallery and various other bits. There's an off-topic channel if you just want to talk about nerd stuff and whatever. Feel free to jump in there. We also have, like I said, the forums. Yep. Okay, code signing. This is something new. I mentioned it earlier. This is something we had to purchase, and your donations help to cover those that have donated. Again, thank you. We couldn't do this without them. The download page, if you've been here before, used to have a big, bold red. We keep getting flagged by antivirus, and thus we've had to password protect our zip files. That was to stop Google, primarily Google, from thinking we had malware on the website and putting up the safe search stuff and blocking it, and even blocking my business's website because it's related to me. It caused all sorts of strife. But about 3 months ago now, I was able to acquire a code signing certificate for Windows that allows me to sign our binaries, which stops antivirus software from false flagging on it and telling everyone we have a virus. So the zip files are no longer protected. You can just open them. The installer is also signed. The signature they're signed with is registered to my business. Code signing certificates have to be connected to an entity, either a person or a business. Looking Glass is not a registered entity. It has no company behind it. There's no company backing Looking Glass at this time. This has all been funded out of my own pocket and my own time, and those sponsoring the company, or not company, the project through their donations. As such, getting a code sign certificate registered to anyone but my full name, which I'm not keen on using as a signing certificate, required a business entity. So it's actually registered to my company, hostvision.com or HostVision. So if you see it signed by HostVision, that's what you want. If it's signed by someone else, or if it's been tampered with and it's complaining about signature verification, well then you've got either a corrupt file or you're getting it from somewhere you shouldn't be getting it from. Looking Glass is free software. Don't ever pay for it. Don't be expected to buy it from someone. Just jump on the website and download a copy from there. The source is also available. On the download page, something you should cover too is the difference between a stable release and a release candidate. People get this confused all the time. A release candidate is a version that is being tagged for the next potential stable release. So it can be newer than the stable release and it can be older than the stable release. At the moment, B5 release candidate 1 is tagged. That is newer than B4 because it's B5. But when B5 final is released and it's here, it's newer than the release candidate B5RC anything. So if you come here and you want the latest stable version or semi-stable version, grab the stable version that says B5, not B5RC1, RC2 and so on. It is older, thus the big red text saying this is not stable but a release candidate. For a lot of people, this may be sort of obvious, but we actually get a lot of people coming in and complaining of problems and showing us their log, and we see they're running release candidates, and it's just like, why? There's some confusion there. The source code as well is available here. We do not encourage building Looking Glass from GitHub or using a Git checkout or downloading the Git archive. The reason being is Looking Glass has several sub-projects and the version matching in them is critical. We have just recently put some checks in the CMake to make sure, or try and make sure you're running on the right submodule version if you do decide to go that path and that route. But if your submodule versions for LGMP or PureSpice do not match the client application or the host application, they will not work. The archives provided on the website, these downloads, are prepared. They have all the submodules in them. They have been stripped of all the Git stuff, so they are literally just a bare archive, source archive, of what you need to build to run alongside the host binary that matches that source. If you want a different version, you can go down the list, so you can see we can get a beta 4, beta 3, beta 2, beta 1, and the corresponding source code, host executable, and documentation for that version. Same for release candidates. You might notice they don't all have documentation. That's because these versions, we weren't using Sphinx stock yet. We didn't have documentation. That came in at B4 RC1, maybe a bit earlier. So you can go down, if you want the bleeding edge version, again, there's the host version for it, and there is a source archive for it, and the documentation for that particular version you're working with. It's important you use the documentation for the version you're working with, because there might be new dependencies, there might be new compiler options, there might be new setup instructions that have changed. For example, B5 RC119 has a documentation update that will be instable on the changes to the configuration for, I believe, the kernel module. Yes. This has changed to a JSON format if you're using the newer versions of QEMU and libvirt. We do have the older version, but the older documentation doesn't have this information. So make sure you're using the documentation for the version you're running. That's important. All right. Let's start looking at some of the cool stuff. The kernel module. This actually happened in B4. A lot of people don't know about it because it used to only be for virtual machine to virtual machine mode, where you're running two virtual machines and you want virtual machine 1 to talk to virtual machine 2, and the host is sort of out of the picture. Now it can run in VM to host mode as well. The reason why this is useful, if you're using a non-NVIDIA graphics card on your host, it has to be non-NVIDIA, because at this time, the NVIDIA drivers do not support DMA buff transfers. They claim to. They even announce support for it, but it's broken because they have decided to implement it in some weird and wacky way that doesn't support a true DMA buff. It's only can share DMA buffs that are created by an NVIDIA device with an NVIDIA device. It's really limiting. It's almost pointless. Anyway, so if you've got an AMD card or you're using an Intel iGPU, especially iGPU users, it's really handy for on laptops because it will save you memory bandwidth. This is for you. So if you scroll down, you still need to do the whole, prerequisites. You need to also install it using DKMS is the best way to do this, because it will manage rebuilding it when your kernel updates. The module will always be available if you use DKMS, so it's highly recommended you use that. You note here, we've got this for VM to host with DMA buff, mod probe with the parameter static size MB for megabytes. So this will create a shared memory segment, 32 meg in size. That's big enough for like 1200p, 1440p, but if you want, say, 4K, you'll need 64 meg or maybe even larger. Depends on what you need. That comes back to the calculations on the shared memory size. What that will do is it'll create a dev KVMFR 0 device, and that's the shared memory device. Instead of making Looking Glass connect to dev SHM Looking Glass client or Looking Glass, you'll now set it to connect to dev KVMFR 0. The client will know it's talking to this special dev node. When it connects, it can detect that. And if it's able to, even with NVIDIA, it'll try and use a DMA buff for transfer. A DMA buff allows the video card to take the image or the frame from shared memory straight into itself using its own transfer engine. It doesn't have to use the CPU to copy that. It takes some of the load off the CPU. It also takes some of the load off the memory bus, because we're not doing a secondary copy. So it alleviates things on laptops where you're trying to run high resolution and you are using a iGPU which shares the system memory already, and you're already bandwidth limited there. So it's highly recommended. Good for desktop users too. If you've got an AMD card, you might as well. It doesn't cost you anything in performance to do it. If anything, it'll reduce system load and improve performance. There's a fair bit of information in here on how to configure that for IVSH MEM in QEMU for libvirt and standalone. At this time, libvirt does not allow you to specify the memory path to the dev KVMFR node. This feature's new as before, and at that time, before then, they didn't see a need to be able to specify the full path to the memory backing file. So to do it, you unfortunately can't use the shmem XML tags. You must go back to using the command line arguments and provide it manually. Make sure that you select the right arguments for the version of QEMU or libvirt. They changed recently, and if you use this one with the new version, you'll get the error about PCI slot not available, blah, blah, blah. So you'll know you've put the wrong one. Thanks to the guys over on the VFIO Discord for actually documenting that and finding a solution to that issue. What next? All right, okay, features, new stuff. This is some of the really exciting things. I'm only going to cover some of the more major features. The whole changelog will be available when B5 is released, the high-level changelog. If you want, you can dive through the commits. There's hundreds and hundreds of them, so have fun. But we do have a high-level list of changes that will be released. So the first feature and foremost, as you probably know, holding down the escape key, which is by default scroll lock, would bring up the help, but the help looks different. It used to be a blue window with white text. Now we have a nice transparency on there. It's this nice grey box. At least I think it's nice. And the font may be a bit different because I changed the font on my configuration. I think the default's free something. I can't remember. But anyway, you notice that's different. That's because we are now using the ImGUI library. Yeah, this is an open source graphical user interface for applications that render OpenGL, which is really cool because it makes it very easy to do overlays with controls and stuff. And as such, we've implemented one. By holding down the escape key and pressing O, you'll actually see on here, down there, we actually have that listed to toggle overlay. And that brings it up. It's like the Steam overlay. We like sort of grey the screen a bit, so it's obvious we're in overlay. And we can interact with everything here without messing with the desktop. To exit overlay, either do the same toggle with the O, escape O, or just press escape. That'll exit the overlay too. On the overlay, we have firstly a bug I've got to make you aware of. We know about this one, and we don't have a solution yet because this is a bug in ImGUI itself. We're using ImGUI to show the alerts on screen for capture enabled, disabled, and so on. And unfortunately, on the first frame, you'll notice it crops off the end, or it makes it too wide. It's using the wrong dimensions on the box based on the last message shown. We know about this. It's not something we're worried about because it's minor. You can still read that. You know what it's doing. We would like to fix it. If you've got a fix for it, yes, please. But it's not a priority at this time. Anyway, bring the overlay up. We have multiple tabs here. About tab. So we've got copyright, the website, our license, which is still GPL v2. Links for help and support. So documentation, the wiki, Discord, the Looking Glass section of the Level 1 Techs forums. One thing I forgot to mention about the docs is they are targeted at Debian. Not Ubuntu, not Arch, but Debian. Most of the instructions will apply to the other distributions, but some don't. For example, the installation of the dependencies and so on. As such, the wiki has been kept up to date by the community, and it has the installation dependencies for the different platforms such as Fedora, Arch, Ubuntu, and so forth. So go over there. I do know at this time, though, it hasn't been updated for the B5 dependencies because the wiki is only targeting stable releases. It should be updated in the next few days. So don't stress about that. If not, it's pretty easy to look through the list of dependencies in the actual documentation and see what's there and look them up for your distribution. We also have the Looking Glass team, so you can learn a little bit about all of us. So they all expand out. Sponsorship links. Remember, sponsorship, it really helps, and it covers the cost of all this extra work we're putting into this, and helps us do cool things. You got Quantum, and you've got Zane and JJR, who are listed here, and a bit about each of them. Become a major supporter of Looking Glass and start contributing lots of code or time, and you can jump into that list too. Settings. Not much in here yet. These are expandable. We can turn on performance metrics. This is a new thing. The performance metrics help us to diagnose what's going on. It also helps you tell what's going on if your virtual machine is not performing optimally, if you're getting poor frame rates or poor performance. The frame graph here is telling us our render rate. Right now, because the overlay's open, we're rendering every frame and we're matched to my screen's refresh at 59.95 Hertz. And you see we've got very, very little jitter in that. It's actually really clean. Upload is frames coming from the guest or updates from the guest to the client. There are no updates happening right now. Nothing is changing on the client's screen. So there's nothing happening. We're saving it oodles of bandwidth because we now do damage tracking. We know nothing's changing, so we're not sending anything. Render is how long it's taking us to render each frame that's being shown. So the overlay and stuff. When we turn filters on and stuff, this may increase because the GPU is doing more work in the client. And it's a good way to tell if it's running slow because your client GPU is too slow, or your host machine's overloaded, or your other VM if your other VM's overloaded. Import is how long it takes the graphics card to load the image in from shared memory into its own memory. This helps us to diagnose bandwidth issues. If this is exceeding the frame rate of your monitor, if it's well below it, say this is like 10 Hertz or something, well then, and you're refreshing at 60 and your title's running at 60, that means you're bandwidth limited. You're having trouble getting the frame from memory into your video card, and you need to look at setting up KVMFR with DMA buff if you haven't already, or getting a faster machine, basically faster memory. There's not much you can do about that. Maybe move your video card into a different slot where it has more bandwidth if you've got one with more PCI Express lanes. There's not many things you can do about that, but that's a good indicator of your bandwidth and consumption of that. You'll notice if I close the overlay, this stays open and it's no longer interactable. This stays on screen. And you can see now if I actually make updates to what's going on, you'll see the upload actually starts to show stuff, and we're now locked at 60 Hertz on both while I'm updating the screen. Render is running at 400 Hertz, which means it doesn't mean it's rendering 400 times a second. It means it's capable of it. It's taking 2.4 milliseconds average to update each frame. Doesn't mean it's actually rendering to screen at that speed. And the import, our average was 1 millisecond. Is great for this setup at the moment. Moving the mouse, of course, causes render, and so on. When the overlay is open, it just renders flat out because it needs to show interaction with all of this. Anyway, so we'll turn that off. Under EGL, we have the damage overlay. This is used for diagnostics. You don't really need it. What it does is it highlights the area of the screen that has seen updates. And that's the area of screen that is actually being transferred from the host to the client with the new damage tracking that Quantum and Xyan implemented. This saves a ton of bandwidth and makes the system more responsive for desktop interaction for general work tasks like CAD or office work or Fusion or who knows, like Photoshop, whatever. Or even games that don't change much on the screen from frame to frame, like card games or board game type things. But we can turn that one back off. We don't really need that. We have the scaling algorithm. That's for when the Looking Glass window is scaled up or down. We can change how it does that based on your preference. That's entirely up to you. And night vision mode, that's still there, and that's toggleable still off the shortcut too, using scroll lock N. Handy for people with aging monitors with dying backlights. That's primarily why that's been added, or those with vision impairment that have trouble seeing things, especially in games or titles where they have a night cycle, and the night cycle becomes basically pitch black to them. I actually struggle with that, which is why that feature even exists. We also have the filters tab. So over here, this is one of the biggest and most exciting features for B5. A lot of effort, a lot of time went into redeveloping a lot of the rendering pipeline for both, or mainly for EGL. Sorry, I'll correct that, only for EGL. This is only supported on the EGL renderer. The OpenGL renderer does not support filters. That is why the tab is called EGL filters. So if we have a look in the list here, we have several things here. We have a downscaler, we have AMD Fidelity FX CAS and AMD Fidelity FX FSR, which is the Fidelity FX Super Resolution. CAS is contrast aware sharpening. That's actually turned on right now, so it's actually already improving things. We'll turn it all off though, just for demonstration reasons, for defaults. As defaults, everything's turned off. Now, the downscaler doesn't make much sense until you sort of understand how FSR works and what it's doing. FSR is a means of upscaling your screen or your image to fill a high resolution screen. A lot of games and titles are using FSR to be able to render, say, at 720p, but output at, say, 1080p, or rather render at 1080p and output at 4K in order to fill a large high-resolution monitor without it looking absolutely terrible. It's very, very good at that. It does an excellent job. It's really impressive. And that's the target market for that technology. There's nothing stopping it being used for other things, though. The downscaler allows us to apply it to anything. Looking Glass itself does already, but if you run a modern application, like even something like DOSBox with an old title in it, like say Commander Keen, or you run even a remaster of something like the original StarCraft, they will run at your desktop resolution, but the application renders the game, or in the case of DOSBox, the DOS environment, it stretches it to full screen. So it's actually running at your desktop's native resolution, and FSR doesn't know that. It's got no way to upscale what's already been upscaled. So the downscaler allows you to tweak and tune. You notice the background there, it just went pretty horrible because it's doing nearest pixel downscale. It's half the resolution now. It's using the downscaler to drop that back down. So what you do is you tweak and tune this and find the perfect spot where you sort of don't see a change for your title that makes it look nice and sharp, and you can see all the individual pixels. And once you've got that tuned in and dialed in, you turn on FSR, and you'll see in the background there's a slight change, but not really much because we're not using it properly here. The other option is not to worry about the downscaler at all, and you can run, say, I don't know, a modern AAA title of some kind that's very demanding and your video card isn't quite quick enough to do it at full screen resolution. You could run it at 720p, something that's older, even an older title like, I don't know, Subnautica, for example, that technologies like DLSS and FSR didn't even exist when that came out. So we can run that at a low resolution and then use FSR to upscale it to full screen, allowing you a smooth experience on a lower end graphics card. Very handy, especially for laptop users too, where they have limited memory bandwidth with iGPUs, with the shared system memory issue that they have. They could actually run their guest machine at a lower resolution and use FSR to scale it back up to their monitor's resolution. So it's a way of giving them an option when their hardware is limiting them in the way that their laptop's configured, which is a pretty cool feature in my opinion. These can also be reordered. You can drag these around, whatever suits your need, and play with them, see what you like. It's entirely personal preference, what works for you in what title. It's sort of like your artistic option. This is a pluggable, it's pluggable in that we can add extra filters fairly easily. It doesn't actually load plugins per se, but we can add extra filters, and we are planning on some extras. Ones such as a grayscale or an inversion tool for making the screen easy to read at night if you say just reading however documentation, or you're using a tool that's hard on the eyes and they've got no dark theme mode or something, or you're in low light, or who knows. But some filters there just to help general usage of your PC, the virtual machine. Also, there's been a lot of interest in porting NMA 4K, the filter, into this as well, in order to make it that when you're watching anime cartoons, videos, playing an anime game, who knows, you end up with that nice real-time scaling of the anime using those nice filters that sharpen everything up and make it nice. The nicest part about this, though, is all of these filters are running in the client. They're not running on the host. So if you were to benchmark the guest, they're not running on the guest. If you were to benchmark the guest while these are turned on and off, there'll be zero difference because they're not running in the guest. They're running on the client application on your host or in another VM if you're doing VM to VM. The other nice thing is if you're a streamer, you may want to, for example, sharpen up the screen, or you might do what one of our streamers does on the Discord channel, Corrigan, you know who you are. He will record, he'll play his game, at 720p, even though he's got a high-res screen. He'll play his game at 720p and capture it into OBS using the Looking Glass plugin, which we have. It'll feed straight into OBS without having to do an extra screen capture, which is really nice. But he'll record that raw and feed that out onto his stream. But then he'll play it using Looking Glass and use FSR to scale it back up to full size, so he can still experience a full screen experience. He can be immersed in the title, but people watching the screen at the lower resolution can still read all the text on the screen. All the messages and all the little bits of information, all the small details aren't lost through compression due to limited bit rates, or because they're just too small a detail once it's stretched down to 720p. So you can do some pretty nice things using these filters. CAS is really nice too, because sometimes you'll get something that's maybe not very sharp, or I don't know, you're watching a video even on YouTube that's been poorly recorded, or I don't know, some images that are bad, but like fairly blurry. You turn on CAS and it applies it to everything. We can push it right up to make it very obvious, and you'll see that this image here has become quite overly sharp. If we set it back down to maybe 0.2 somewhere, 0.1, something like that, it's actually quite visible. Sort of hard to see, probably won't show up too well on the stream because of encoding, but I'll toggle that a few times and you should be able to see that it's actually having an impact there. If we were to do that on a, I won't put a YouTube video on or something as that because I don't want any copyright issues with this video. But yeah, it sharpens up things quite nicely, and play with that. Have an experiment with it. It's fun. What I'm going to do now, though, is also demonstrate what FSR does. So I'm going to run up, that's the folder. No, not that. I don't have that. I want BattleNet, if I can get it. There we go, BattleNet. And launch the original StarCraft, the remaster of the original StarCraft. The reason why I'm choosing this title is because I've done some experimentation. I already know the parameters needed to make this look good. So we want to, if you're using, for example, this title, it has a scaler built into it already, and a video, SD graphics filter, and normally this is like up here at filtered. And you'll see everything's sort of soft, the edges are quite soft and everything, and it doesn't look too bad really. And we'll go and start a game. And this is stock. Actually, I think I've got CAS turned on still. We'll turn that off too. All right, so this is absolutely stock at the moment. Yeah, it's playable. Doesn't look great. Let's maybe turn, forget that. We'll go into the options and we'll turn the filter down a bit. We'll get a bit sharper. It's starting to look a bit better. So this is stock still. Let's turn that though right down so that it's not doing any filtering. So this is now what we call nearest scaling. We're seeing every single pixel as it was rendered. It's no longer doing any filtering, and it's sort of chunky DOS style graphics as you would expect. What we can now do is in the overlay and turn the downscaler on, and now I already know that this title, not sure why I'm not getting exact, but this title is a 2.0 pixel ratio. So it's actually running at 960 by 600. So this just turned everything on. I don't want to turn it on yet. So if I turn on the downscaler, you'll see that we're sort of getting close. Maybe I'm a bit off on that, but you get the idea. We want to scale it and we want the nearest pixels downscale. And you want to get that to the point where you don't see a change when you toggle it. It must be off a little bit in this because there is a point where this doesn't actually have much of a change. Yeah, I think it's like 2.5. Close. Anyway, it's good enough for the demo purposes. You'll see now that's downscaled. I bring it up again and we'll turn on FSR. Look at that. All the pixelization is gone. We have sharp edges on everything. And it looks schmick. This game came out in what, 96, 95? 95 graphics. And that's what we can do with it. Now, the FSR and CAS, because we're using a hardware mouse, this game uses a hardware cursor. It's not affecting the mouse, so we don't have to worry about that, and we're still getting a sharp mouse too. But that's just one example of what it's capable of. So if we turn on CAS, you can see straight away in the background the sharpness difference as well. It just pulled out all the detail. Now, because we're already using FSR and it also does its own version of CAS as well internally, it's probably not a good example here, but you can just see that there's a lot of potential in the way you do things. There's also the ordering of these can affect the results as well. So play with it and see what suits you best per title, and then you can go and save presets and load them again later soon to figure it all out again. Very cool things. So what else do we have? That's all the overlay stuff we've done. We've also got, I discussed damage tracking already, but damage tracking isn't just about saving bandwidth, communicating from, copying the frames from the host to the client. It also allows us to tell the compositor that you're running, if it's Wayland with a GNOME or KDE or something on there, or if you're running Xorg with Compton, we're actually able to report to the compositor via EGL what areas of the screen actually updated, and it improves the compositor's overall performance and latency. It helps it be more intelligent with how it redraws the screen, especially if areas of the screen are obscured by other applications. So damage tracking is another big feature for B5. Another feature that initially Quantum added, we've titled JIT Render. We've coined it JIT Render. Stands for just-in-time rendering. By default, this is turned off. And what it does is, instead of just rendering every frame, keeping up with VSync, or if you're not using VSync, which you shouldn't be with the Looking Glass client if you are, there are better alternatives to using VSync. VSync will introduce latency, and it's turned off by default for good reason. If you've got no choice but to turn it on to get rid of tearing, and you haven't gone and asked in Discord or asked for help or done some research on how you can solve it on your system, hint, tear free, that's a good keyword to search for, or NVIDIA Force Full Composition Pipeline, or look at running a compositor like Compton. It works well with Looking Glass. There are solutions without turning on VSync, because VSync introduces lag and latency 100% of the time. Why we turn it off. But anyway, JIT render, what it does is it waits for, especially in Wayland's case, it waits for the window manager, or display server I should say, to report that it's just about to draw a new frame to screen. VSync's about to happen. At which point we can grab the latest frame that came from the host into the client, and we can render the latest data we have, the latest frame we have to screen at that moment. This reduces latency substantially. If you're running at 60 Hertz, it can remove 14 to 15 milliseconds of latency in the pipeline to get the frame to screen. Under Xorg, it doesn't have a extension for this. It doesn't have a way to know if the frame's about to be rendered, but there is an extension called XPresent that I figured out how to misuse, essentially, to emulate the same feature in Xorg. And using that, it is able to calibrate and sort of figure out the optimal delay from each frame being rendered to render the next one, and sort of synchronize that way. And it works very well, but there is a big caveat with it. Because it's not designed for this, and it's pretty old now, on a system with multiple monitors that are varied in model and type, where they're running different refresh rates, XPresent will actually synchronize to the slowest monitor. So if you have a 60 Hertz monitor and a 144 Hertz monitor, it doesn't matter which is the primary. Under Xorg, with XPresent and JIT render, it will synchronize to the 60 Hertz monitor, to the slower one. There's nothing we can do about that, I'm sorry. Next thing that was added, Quantum went and finished and added the DMA buff support to OBS, the OBS module. So if you put Looking Glass into OBS, it's highly recommend you go and set up KVMFR as well, as mentioned earlier, and use it with OBS, because again, it's going to save you bandwidth, and it's going to save GPU load, it's going to save memory load, all those good things. If you have an Intel iGPU, using a laptop, or you have some other machine with an embedded iGPU, who knows, there used to be a problem that was called cursor flickering, or the cursor to be a black box, or it would cause the overlays and alerts to not render properly. Those issues have been fixed. It was an issue to do with the depth buffer. Looking Glass is not a 3D application, but it's using a 3D API to render. And as such, the Intel graphics cards insist that the depth information be valid and correct, and I was not doing that. Quantum tracked that down and fixed it, so now you should have a flawless experience on those GPUs that were causing problems. That's pretty much it for our big changes coming into Beta 5. This video has been quite long. I think we're almost at an hour or pretty much into it. I had to restart the video because of my camera battery went flat. But yeah, we're something like an hour in. So I'll touch on just quickly the future features that are coming after B5 that we've already got working on or finished. There's two major ones at this point. One of them is cursor scaling. Now, that's not input scaling. This is cursor, actual, like the icon physical size that's rendered on the screen scaling. When you are in Looking Glass, like we are now, if we go to a window mode, you'll notice the cursor got smaller. Oops, we want to uncapture, hold on. The smaller the window gets, the smaller the cursor gets. And it becomes, especially if you're on the desktop at this kind of size, the cursor becomes so small you can't use it. If the desktop's running 4K for whatever reason, maybe using NVIDIA DSR in a title that uses the mouse, the cursor becomes so small you can't see it, or it's tiny, especially if you're going from 4K to 1080p or something. Cursor scaling will maintain the 1-to-1 ratio, so the cursor size is always correct. You can turn it on and off as you need it through a command line option. So if you prefer it to scale, that's not going to change. You can still have it that way. Another feature that's coming that's super exciting for after B5 is audio support. Now, if you have tried to make audio work in QEMU and libvirt and so on, you'll know that it's a nightmare to get it to function properly unless you do one of three things: either muck around for hours and hours trying to get the environment variables set up and configured, and period sizes and so on, buffer sizes for Pulse Audio or ALSA to make QEMU output the audio directly. Or you could use the Jack Audio backend I wrote some time ago, and while that works somewhat easier, there's still a lot of fiddle in setting that up. It's not very easy, and it's more a professional routing tool that requires a lot of intimate knowledge to configure and use. So they're not really easy. The other option people have been using is Scream, which is a Windows virtual sound device. It'll actually stream the audio over the LAN. You can also stream it over shared memory, but there is no reason to do that. It actually uses a lot of CPU time to use that, and even the Scream's documentation officially says there's no point in using it for this. So don't do that if you can avoid it. And the third option people use is to pass through a whole sound card into their virtual machine. They'll plug in a USB device, or they'll put another PCI device in there that's a sound card and pass that into the machine. Or they'll use the HDMI audio on their graphics card. Now, that works, but then you've got the issue of you now got two sound devices, and you might want to combine them into a single output, and you've then got to get cables to splice and maybe break out the digital from the HDMI, and it's not a nice solution either. Over the last couple of weeks, I've been pondering about this and looking into documentation, and the last few days I've implemented the start of an audio layer in Looking Glass. So far, Pipewire is fully implemented in a functional way in the audio branch. This is all available on GitHub under the Looking Glass project in the audio branch. And Pipewire support is working. I'm actually using it now. I've been using it for this entire video. You'll see over here, we actually have in the PAVU control, Looking Glass. This is actually running the Pulse Audio layer on top of Pipewire, so you can see it here, but Looking Glass is native Pipewire, is what it's using right now. And what's even nice is if I grab this and we'll get the Windows volume control up. See over here on the right, we've got the Looking Glass volume. This is actually synchronizing with the guest. So we have full audio coming through Looking Glass. The advantage to this is we are bypassing all of the audio output code in QEMU that A, can be running under a different user, so it makes it really hard to get the audio out of it. You've got security issues and so on. And B, bypasses the bugs in the audio output code and the complex configuration is set up. Now obviously you won't have audio unless Looking Glass is running, because it's now handling the audio. But as far as the setup process for making this work goes, it's really simple, and which is why it's so exciting. All you have to do is add a virtual Intel HDA audio device to your virtual machine. In libvirt, it's literally 3 clicks. You click Add Hardware and choose Intel HDA. Say OK, done. Launch your virtual machine. Launch Looking Glass with Spice, because it's done over Spice. You must have Spice support enabled. You don't have to use Spice for input. You can tell it to just use it for audio if you don't want to use it for input. But launch Looking Glass and you'll have sound. No pops, no clicks, no issues unless you have not configured Pipewire correctly. The audio interface I've been building into Looking Glass is agnostic. It will support multiple backends. At the moment, it's only Pipewire because that's the first platform I've targeted, first API I've targeted. Coming next will be Pulse Audio, and perhaps jack and ALSA. It depends on available time and demand for those things as well. Pulse audio and pipewire will cover probably 99% of use cases. So the drive to develop on pure ALSA, which is never fun, is pretty low. And jack, it's not particularly hard, but it's more time that may not be necessary if no one's really going to use it or find it useful. And it's more code that would need to be maintained. So there's still question about whether or not jack and ALSA support in Looking Glass, in the Looking Glass client will ever happen. But just to be clear, this is not shared memory audio transfer. This is over the socket that Spice uses to communicate. And because it's all local host, it is essentially using shared memory, especially if you configured your guest properly and you're using VirtIO Net, in which case it's basically free to transfer data across them because it's using shared memory transfers anyway. And the output is outstanding. The code's only a couple of days old and it's already feeling like it's production ready. So exciting things coming after Beta 5. And that's about everything I think we needed to cover here. I would like to thank the donators again that have been sponsoring this project. Hopefully those that have seen this video and watched it are seeing how much effort and time is going into this and the value of what's being produced. There's so many ways to use this that even I haven't thought of. For example, the way Corrigan's using it to scale his streams up for Twitch is something I'd never thought of. In the use of FSR, it's very cool. The audio stuff's very cool as well. I'm very excited to be writing that and getting that out there. But all of this takes time. All of it takes effort. Some of the things take actually purchases, such as the code signing certificate. I've had hardware failures. I've had to replace hardware in the system. And as you know, at the moment with the pandemic and the chip shortages and the scalpers, it's very hard to get certain hardware like video cards and so on. And if you can get them, the prices are absolutely abysmal. So donations to support Looking Glass are absolutely necessary at this time, especially if we want to see some things I would like to implement in the future. One of which is what we call an indirect display driver. Microsoft actually have a driver sample already that can be used to prove the concept, which I've already done. And now we have a code signing certificate. We can actually create our own driver and sign it. That's a possibility for the future. But the development time to write a Windows driver that is useful to this project is enormous. The time investment is huge. The mental investment is huge, and I can't justify at this time investing that much time into a new part of this project at the moment and still be able to focus on the rest of it. So if people want to be able to have a muxed laptop, be able to use a virtual GPU with Looking Glass, or even just without Looking Glass with a virtual monitor, that's what the funding's needed for. It also may, I can't say for certain about this because, again, would have to dig into it fairly deeply. It may give us access to capturing the Windows output inside kernel mode and avoid the issue of mouse movement causing frame jitter. There are a few things that it will open up to us, few doors it'll open up to us, some maybe even special workarounds on transferring memory straight from the GPU into shared memory, bypassing the intermediate copy in Windows. A lot of exciting things there, but without financial support from a large number of people or a corporation, this part of Looking Glass likely won't get built, as much as I'd like to have these features built in there. So donations are important to this project. I hate asking for cash, but it's the only way to get these extra things in there. But those that are donating already as well, greatly appreciate it. Those that are using it but want to donate and can't, no worries. No pressure, no stress. I'm just happy you're using something that I've created, and well, sorry, not me, our team has created now, and it's made your life easier. So with that said, I'm going to sign off now and go and edit this video together and hopefully get it up at or before the B5 release. I'll be on Discord if anyone wants to jump in and say hello, or if you've got any problems or need some help, come and join us there and have a chat. I'll catch you all later.